As I said, you can get the handouts in the handouts feature of GoToWebinar. Also, we'll be posting these to the CSOHIMSS website. If you look under the events and education section, there's a link to past events. We have a link to every one of the previous CSOHIMSS Lunch and Learn webinars, all of our past events. You can find handouts, slide decks, CEU forms, and whatnot. And also, while you're there, check out information on our upcoming events. We are recording today's presentation, which you will find on the CSOHIMSS YouTube channel here in a few days. If you would like to contact CSOHIMSS, if you're interested in becoming a member, becoming a sponsor, or just a general question, you go first to our website where we keep tons of information. You can email csohims.president, which will go to our current president, Mr. Ryan Clark. And if you email csohio.info@himschapter.org, it goes to pretty much the entire board. We do try to stay active on social media, or at least provide updates on upcoming events. We're on Facebook, Twitter, and LinkedIn. We would like to take this time to thank our sponsors, because without our sponsors, we could not provide educational opportunities. Though we are a chapter of HIMSS, we don't get a lot of money from HIMSS. So it's our sponsors that allow us to provide our members with great events and great education. This year's premier sponsors are HPG, IBM Watson Health, Cover My Meds, OnBase, Newtonics, and our presenter today, CrossChx. Our elite sponsors are Tech Systems, DMI, Vocera, Spectrum, Leidos, Innovative Consulting Group, RDI Corp, Merge, Encore, and Metasource. I want to share just some information real quick on our upcoming events. The big one is this Friday, and there is still time to register. Our fall conference, Interoperability, the Holy Grail of Healthcare, is taking place down in Westchester, just outside of wild, wonderful Cincinnati. We have a link here, but the easiest way to find it, go to Eventbrite and search for CSOHIMSS. Go to the CSOHIMSS website, and there will be a direct link to the registration. Hurry up and register, because I do believe we are cutting off registration tomorrow by noon. But if you got time, do it now. Next big event we got coming up is the Ohio Healthcare Information Technology Day, and this will be the 11th annual OHIT Day. Takes place Wednesday, April 25th in the Ohio State House atrium. Keep an eye on our website where we'll put information as things develop. Our spring conference will be at OCLC in Dublin, Ohio. We're pulling together topics, looking for presenters. If you have something you'd like to present, by all means, contact one of our board members immediately, because we are going to get the spring conference knocked out and everything put together as soon as possible. We'd like to share some information also on our upcoming Lunch and Learn webinars. This is actually, today's webinar is the last one that I have a presenter for. So if you have a project you want to share, you are an expert in a certain field or area, or if you just need some good presentation experience, contact me. Again, my name's Scott Mash. Just go to the CSOHIMSS website, go to About and then the board, and you'll find my email link. Presenting for a CSOHIMSS Lunch and Learn webinar gives you valuable points towards advancing to a HIMSS senior member or a HIMSS fellow member. So with that, I am going to turn it over to Mr. Sean Lane as soon as I can find him here in my list. All right, Sean, I have unmuted you, and you are now the presenter.
Okay, it looks like I'm sharing. Thanks, Scott. I appreciate it. Let me switch to presentation mode. Can everyone see my screen? Am I good, Scott?
You are good, sir.
Great. Well, thanks so much. I really appreciate the invitation today to be able to share a little bit about what we're doing. Today I'm going to talk about scaling humans with artificial intelligence. Really appreciate your time. Thanks to everyone who's on today in the Lunch and Learn. The first thing I'm going to just review very quickly are the learning objectives for today. You know, I'd love for everyone to walk away with a little better understanding of AI, how you can implement it today, not just years in the future, and how AI will scale humans to achieve more. That's the theme of what we're going through today. I want to start with just some background about me. So that's my picture. I believe that is in Iraq, in Fallujah, I believe. So I am a intelligence officer by training. I grew up in southeastern Ohio in a small town called Gallipolis. I went to Miami University, and after that joined the Air Force as an intelligence officer. Spent most of my career as an intelligence officer at the National Security Agency, NSA. I was always a tech nerd growing up, and when I was in the intelligence community, I was very fortunate that being an intel meant, being a tech nerd in a lot of ways. We really, at NSA, got to work with an enormous amount of data. You can imagine the volume that we were dealing with. When I was in Iraq and Afghanistan, I did 5 tours across those 2 countries. We were dealing with a couple 100,000 of rows of data every second, and we had to figure out how to database all that. We had to break down silos between different agencies, which is a lot like breaking down kind of the data silos that exist in healthcare, and then make sense of it all. So all that data was super heterogeneous, coming in from different sources. We had to make sense of it. We had to create software applications on the front end for our soldiers out in the field to use it to track bad guys. It was an incredibly rewarding experience, and even though in this picture, it looks like I'm a shooter, really this was me. So when I was in the military, I spent most of my time behind a computer, whether it be coding or working with other engineers. That was how I, fought the war. So it was a really incredible experience. And then in 2007, I got out of the military and started my first company in Baltimore, Maryland. It was a software company. We built basically advanced analytics, intelligence tools for the intelligence community. Just some history, I sold that company in 2011, and I was still in Baltimore, Maryland. And about that time, my hometown of southeastern Ohio said, hey, we're having some problems with prescription drug abuse. Do you think you could help us out? And I had a lot of friends and family that were affected by that problem, so I wanted to try to help as best I could. I knew the CEO of the local health system there, Holzer Health System, and started to take a look at their data. And the first thing I realized was that healthcare didn't really have an identity layer, and what I kind of coined as healthcare didn't have the internet. So no way to really share information about patients across multiple pieces of software, no way to share information about patients across systems. And that's where really CrossChx began. We started looking at patient data to create a single unique ID for every patient to solve those identity problems. We ended up launching that identity resolution capability in a few hundred hospitals around the country. And this year, we've started to focus on artificial intelligence. And the idea is that, powered with the understanding of who a patient is, artificial intelligence can make a real impact in your organization. So we have a concept that we call scaling humans with AI, and that's what I want to start with today. So the first question is, what is scaling? What does it mean? In a lot of the startup world, scaling is growth. Scaling is growing to a big size, being able to apply your technology across different verticals. In scaling humans, it's about being able to do more with less. Unfortunately, right now in healthcare, a lot of the humans that we hire and bring in are spending most of their time behind a computer screen, and they're operating enterprise systems that really make them do routine and mundane tasks, stuff that that technology can solve, and it's kind of frustrating. So the idea here is to use AI so that your humans don't have to do the routine, mundane tasks that they have to do today, everything from managing patient information to prior authorizations, eligibility requests, things like that. There's ways that AI can play in that, and that's what we call scaling humans. So throughout history, humans have scaled through tools. If you think about it, throughout the history of the human race, every time we were able to achieve doing new things at a higher level, it's been because of tools that we have created. For example, the wheel. When we invented the wheel, it allowed humans to do so much more. We could move more things. We could travel more quickly. When fire was invented, it changed the paradigm for humans. That was another tool that allowed us to scale, to do more, to accomplish greater tasks. That picture on the right is the printing press. When the printing press was created, it allowed humans to take knowledge and information that they had and share it with others in a scalable way. That was an incredible invention. All of these inventions of tools throughout history have really scaled humans and allowed them to do more with less. And then, of course, we created the internet. And the internet, it was kind of the next evolution of the printing press, and we could share knowledge and information across the world with other humans, so we could learn more, we could achieve more. It was an incredible invention. The combustion engine was also another tool that we created as humans to help us scale, to travel farther, to fly through the air, to go from East Coast to West Coast, to be able to commute to our jobs, to make our neighborhoods larger. It just made such an impact in the way we live. And then, of course, we created software applications. And this was really important because humans built these on top of the technology infrastructure that was created by humans. There's a story that Steve Jobs liked to tell, and it was about a study that was done. And the study was done to measure the efficiency of energy output as to the distance traveled. And they looked at basically every creature in nature. And the humans were looked at, and as walking or bipedal locomotion, and that was compared against that picture on the left is the condor. Well, the condor was it got the #1 ranking of everything in nature. It could travel the farthest with the least amount of energy expended. The human was pretty far down the list. It didn't really perform well in that measurement. However, when the human got a bicycle, a tool that we created, the human blew away the condor, could travel much farther with much less energy expended. So Steve Jobs liked to say that the computer is the bicycle of the human mind, right? It allows us to go farther and achieve more. What we like to say is that AI is the bicycle or tools, are the bicycle of AI, and I'll talk a little bit about that. So there's different ways to think about AI. A lot of people think about it in just machine intelligence and machine learning. People think about it in advanced analytics. People think that if you get a large amount of data, people can do this magic thing with it to create insights. But the way we think about it, we go back to first principles of what AI is when it was created. And Alan Turing is one of the kind of leading technologists throughout history that have defined computing and helped define AI. And the Turing definition of AI is basically if you're unable to distinguish a human and AI from each other, so human and technology. So is it a human performing the function, or is it technology? And that inability to distinguish is truly AI. In fact, there's a test that a lot of computer scientists use called the Turing test, which allows you to measure a human, the output, and try to determine whether or not you can tell if it was a human or a machine. So that Turing test is something that we still use today. So given that humans use tools, and if humans use tools and we want to make a human indistinguishable from technology, then AI should use tools too. Just like that humans using a bicycle or the wheel or fire or the internet, AI, whatever we create, should be using tools the same way. Now the great thing is, over the past 30 years now, several decades, we have been creating apps. We have been building software applications. In a healthcare environment, an enterprise, you may see these as an EMR, an EHR, a revenue cycle tool, patient portals, web portals for insurance, but these are all apps that we've built. And the idea that we have is, instead of trying to build another software application for hospitals to use, because it seems like every startup coming out of Silicon Valley today wants to provide you with the sexiest software that's so much better looking than your EMR. The challenge with that is the change management, the fact that you've invested so much in this tool, and that these software applications that these companies offer typically only do one thing really well, and they can't really take over your entire enterprise. So what you end up with, if you take it on, is just another screen for your humans to look at. We took a different approach. We said, what if we can train our AI to use the software you already have, to use the EMR you already have, the revenue cycle tool you already have, the patient portal you already have. And we do that through a process called RPA. And I'm not sure if anybody's heard of RPA before, but it's kind of like the basic building block of artificial intelligence. It stands for Robotic Process Automation. And you can see in the picture I used Johnny Number 5 from Short Circuit. And I use this picture because the thing that's prominent here are the robot's eyes. Well, fortunately for us, machine intelligence has advanced a lot over the past few years, specifically in the area of computer vision. Computer vision is the capability for your bot or an AI bot to see and understand what they're looking at. So think about that in the context of software. The bot can look at the software, look at the EMR, look at your revenue cycle tool, and understand what they're looking at, just like a human would understand the tool that they're looking at. So RPA is a fundamental building block of what we're creating. Now, one of the things that we decided at CrossChx was that the integration challenge was tough, that to go into every single health system and to wrangle either HL7 or FHIR or APIs and SDKs with different software was a huge challenge, a barrier of entry even, to do things the way it should be done from an internet level of sophistication. There are a lot of companies out there who's made it their sole mission to homogenize a lot of these integration techniques to make it easier for hospitals to onboard new software. We took a different approach. We said, look, we're not going to integrate, we're going to integrate with nothing. We're not going to integrate with anything. What we're going to do is integrate with everything. The way we get access to data is the same way a human gets access to it, through the user interface. We log into the tool just like a human does, and we get access to the data, the workflow, everything that you've already invested in just like a human does. So what that means is no integration. You can bring AI into your health system, you can have it start working, and no integration is required. The only thing we would need, from our perspective, is a username and password. It's a very interesting way to look at it. Integrations exist with every piece of software that's ever been built and ever will be built, because they were built for humans to use. And our technology and other RPA systems, robotic process automation systems, can use it just like a human. So the second, what I call, the second fundamental building block to good artificial intelligence is this concept of global awareness. And I want to talk a little bit about what that means. So if you remember back, and I told you the story of CrossChx when it first got started, and what we wanted to do is have a global unique ID for every patient. What that really was global awareness, understanding who a patient is across two pieces of software, across two hospitals, across many hospitals. Global awareness, when done correctly, is incredibly powerful. Imagine just in your health system alone, if your machine understood who a patient was and understood that across different software systems. Imagine if they understood the concept of a drug, of a diagnosis, of a provider, of a department, and they could apply that across every piece of software they use, like an external routing table of the most important information. That's global awareness, and we've specialized that in our company for several years, and I've specialized that all my adult life. The intelligence community is very much based on this concept of global awareness. The ability to know you're talking about the same bad guy across the CIA database, NSA database, FBI database is incredibly important. The same as it's important to understand what an IED is, for example, across those different databases. So global awareness is incredibly important. And then the third component or building block to artificial intelligence is machine intelligence. Machine intelligence is the ability, and there's a large spectrum here. It goes from, on the left side of the spectrum, what we call supervised intelligence, where you're really coding and programming what the machine knows and how it knows it, all the way to the right end of the spectrum, which we call unsupervised learning. Unsupervised learning is the machine's ability to learn and act on its own. A lot of those unsupervised learning techniques are very, very new. Not a lot of them are proven, but we're making really fast advances in that technology. Machine intelligence as applied, let me give you an example. let's say, for example, your AI bot is looking at your schedule every day in the electronic medical record system, seeing the patients that are scheduled to come in for a visit, and then sending a text message reminder to that patient to let them know that their appointment's coming up. That AI bot can also see which patients come in for a visit, which ones don't show up. And over time, it can learn how to be more effective. You know, if I sent a text message at 6:07 p.m. versus 4:33, maybe I was more effective to get them to show up. It can also understand the type of patient, the demographics, the signature of the ones who don't show up to appointments, and understand where patients have a higher propensity not to show up, and apply different techniques to get them to come to the appointment. That's one example of machine learning as it's applied to healthcare. So going back to the equation, RPA, robotic process automation, plus global entity awareness, plus machine intelligence equals AI in the context we're talking about it. So we came up with a term here at CrossChx that we call skill bots. Skill bots are super connected, intelligent learning bots, and that's really what we've created. And I want to go through each piece of that to understand what that means. Super connected means that every bot that may be doing a function within your health system, whether it be eligibility, scheduling, patient engagement, they're all connected to each other. They share, for lack of a better term, the same brain. They learn each time any bot does something, every bot learns. This is incredibly important, and think about it in the sense of driving a car. When a human drives a car and gets into an accident, maybe rear ends another driver, they learn. They learn, hey, I shouldn't follow too closely. I shouldn't do this again. Next time I won't. Next time I'll learn. When an autonomous vehicle gets into a car crash, a driverless car, every single autonomous vehicle learns from that experience. So it's much more multiplicative. It's much more networked than a human brain. So every bot that we deploy is super connected. It's also intelligent. So the I in skillbots is intelligence. It understands the context of what it's doing. It understands who a patient is. It understands what a drug is. It understands a DRG, a CPT. It understands a department or provider at a global level, going back to that global awareness. And then learning. Learning is just the idea that it gets smarter over time. It's able to perform its function better. For example, we have a couple AI bots operating in health systems in Georgia. There was a health system there that was the first to adopt our AI bot, and it was performing tasks to essentially find patients that were coded incorrectly, and the organization was missing out on some reimbursements. And over time, our AI bot started to learn that, hey, these types of patients coming from a specific department tend to always fall into the category of not being coded correctly. So our machine could actually provide insights through email to its boss, our bot's boss, saying, hey, I think there's something wrong with this department, this provider, because we continue to see miscoded patients coming through from that area. So it's the ability to learn about what it's doing and provide insights back to the humans. So at CrossChx, we built a skill bot that we call Olive. Olive is our skill bot, or our AI bot, that we deploy to health systems across the country today. The really neat thing is that Olive uses all the crappy software you already have. And you know, I know this is a little bit of a provocative statement, but I think we can all agree that a lot of the software that you deal with on a daily basis probably doesn't have the best user experience, probably isn't the most aesthetically pleasing. But hey, you've invested a lot in it. We understand that. We're not going to come in with a fancy new user interface and say, use this for some things and your other tool for others. Our idea is that Olive doesn't care what it looks like. Olive doesn't care if the user experience is good. Olive can use it just as good or better than a human can. So it doesn't matter, again, if it's the flashiest new version of JavaScript or UI design, Olive can use it. So, because the guts of the system and the way it's all working inside your hospital, in your health system, it all works pretty well. So again, Olive just logs into it like a human and uses it, and we don't have to replace any of that software. And this is kind of an example of the global awareness. Olive logged into one system. Let's say she's logged into a Meditech EMR on one side. and then Olive logged into maybe a portal, an insurance eligibility portal on the other side, share the same brain. So Olive on both cases understands who that patient is and can look up their information across both systems and make sure that data synchronizes between the two. That's an important concept. As we roll out more, you can imagine Olive being able to communicate across different health systems or different hospitals about a patient. You can imagine Olive exchanging things like CCDs and electronic health records of patients, doing referrals, making sure information about identity is the same across different health systems. And then as it spreads, and if you imagine Olive logged into every piece of software that exists. Imagine, Olive logged into your EHR, Olive logged into your revenue cycle tool, and the same across multiple health systems. Then there's this concept of being able to use it together. So let me talk about this picture and how this comes to bear for a patient. What does this mean to a patient's experience? So this is a patient. This guy, he's on his way to Aspen. He wants to meet up with Mary Swanson, unfortunately, to return her briefcase. Unfortunately, he's chipped his tooth, as you can see, and he needs to get that fixed. So he's in Wisconsin right now on his way out to Aspen, and he needs to find a dentist. So imagine a scenario where this person, this patient, we'll call him Lloyd, just for an example, texts Olive and says, "Hey, Olive, I need to go to the dentist." Olive, because she's logged in to the practice management systems at all the dentists in the area, can look at the schedules and say, "I have an opening at 10:30 or 9:30 or 11. Which one would you like, Lloyd?" Lloyd says, "I'll take 11 o'clock. Olive then, because she's logged into the practice management system, schedules the appointment. She has his insurance information. She checks the eligibility through the portal to make sure it's all accurate and up to date. She then goes to all other places where Lloyd has ever visited from a dental perspective and pulls his history together, completes that history in their practice management system. All the forms that he would normally fill out, all completed, all the records and images he's ever had in the past, all put into the new system. And that's all done very seamlessly because Olive has a presence. Now, that is the future. That's where we're going. That's not, there's a lot of things to figure out along that process of getting there as far as information sharing and rights and permissions. But if the patient is complicit and the patient wants to share the information, and we have a trusted authentication layer and identity management layer, this is certainly possible. So this is a picture of a search engine that I think most of you are familiar with. And this was one of the first iterations of that search engine. And the great thing about Google is they created a capability to organize the world's information. They created a capability to organize all the data on the web so you can search it very easily and find things out. Don't we wish health information worked like Google? The funny thing is that even Google, and all of its incredible power and everything that it's created today, it has ignored enterprise data. So there isn't an enterprise version of Google. For all the data sitting in your health system, there's no Google equivalent. Imagine if enterprise data inside a health system could have the same effectiveness that Google has. So again, think back to that example of Olive logged into all those different systems across all these different hospitals. Now imagine asking Olive a question, putting in a search box, "Hey Olive, tell me about this patient." And then every Olive that's logged into all these specific systems turns to that system and queries that patient, queries that information that you want to know, and returns back to you a Google-like result. This is the future that's possible with this idea of AI bots, actually having access to the systems you already have. So there's an important thing in history that kind of runs parallel to what we're seeing today. The image on the left is a mainframe computer. In the late 70s and early 80s, the mainframe was the thing in technology and computing. It was this amazing capability that big companies had that not a lot of people understood. It was kind of magic. We didn't really know how it worked. There were a few computer programmers that had access to it. There are a few computer programmers that could build things on it. But most computer programmers or hobbyists had no access to it. They couldn't do anything with it. All they could do is imagine what it could do. And I feel like AI is right there. It's kind of in the 1977 to 1983 time frame, where we know it exists. We understand that AI seems to do some incredible things. We understand that it's somewhat magic, but we don't really have access to it. It's not easy for us to get a hold of and to use, so we can't really figure out how it applies to our day-to-day. How does it affect my operations today, aside from being sci-fi? Well, the really cool thing in the picture on the right is an Apple personal computer. And it wasn't the mainframe that changed the world. It was the personal computer. It was a couple guys in a garage that made a kit that gave every human the capability to do computing. It wasn't the mainframe with a few people where a few people had access. It was the democratization of the capability through this personal computer that changed everything. Once people got their hands on computing, and hey, the system on the right is way less capable than the system on the left, but the personal computer was in everybody's hands. And humans created tools and technologies and codes, and they created software applications, and that's what really created the power of computing that we know today. And I think we're in a similar boat with AI. It's not going to be the mainframe version of AI, the $3 million, or $20 million implementation of AI in your health system is going to change the world. It's going to be the real operational AI that can impact your day-to-day operation today. It's going to be that democratized access, that ubiquitous access to some AI, even if it's less robust in technology and capabilities than what we may see in the media or understand as far as AI goes today. That democratization is what's going to change everything. There we go. So imagine this. Imagine if there was a platform similar to that personal computer. That personal computer became a platform. That was a piece of technology that allowed people in their basement, in their garage, in their living room, in their office to really build apps, to build the future that we know today. Imagine if the same platform existed where thousands of humans could be building millions of skill bots. Imagine if just a regular person in their dorm room or in their garage could build an AI bot that would log into a few pieces of enterprise software and do something amazing. I think that's how we create the new digital workforce. I think that's how we create the biggest impact of AI, and I'm certain that this platform will come about. We're working on a platform at CrossChx very similar to this. We use it internally now. We call it Mimic. It is the platform upon which we build all of our skill bot. And we're thinking about in the future allowing others to build their own bots on top of this platform to do all those things that we talked about, to be super connected, to be intelligent, to learn. And we think that's going to have a massive impact in the future. Before I open it up to questions, I kind of want to part with this food for thought. And this is a little bit of future thinking, but think about this. Today, every piece of software that you have in your health system is made for a human user interface. So software engineers have built it to be used by humans. So when you're evaluating new technology, you're looking at user interface and you're thinking about your humans using it. I contend that in the very near future, let's say you put to work 20 or 30 AI bots in your health system doing tasks, doing functions, and some vendor comes in to sell you a new piece of hardware. And you know that your AI bot's going to be using that hardware just like your humans are. You're going to want to make sure that that UI not only works well for your human, but also works well for your AI bot. So I imagine in the future that there will be two separate user interfaces, one for humans and one for AI. Think about it in the sense of when you log into a website, they have a version for your laptop and a version for your mobile phone. Just like there's a mobile phone version of that user interface for that website, there will be a AI version of that user interface. And it looks something like this. The one on the left, that's your typical user interface for a human. Drop-down boxes, clicks, file header up top, buttons that you can push to do certain actions. But see, AI doesn't need to look at it that way. AI can look at it in more like the picture on the right, a QR code that maybe changes every microsecond or every millisecond, that provides all the information that AI unit or that AI bot needs to interact with that software in real time. So all the clicks, all the drop downs, all the functionality of software boiled up to one screen so that bot can manipulate and use that software to do whatever task it's been assigned. You could also transmit data through this mechanism, where instead of reaching into a database and dipping in and pulling out information, just as much data can be transmitted through these codes on the screen to that AI that's using computer vision. So that's just something to think about. But now, Scott, if it's okay, I'd love to just open it up for questions and see if anybody has anything they want to ask. Does that sound good?
Absolutely. Let me check our questions here. All right. First question. If a company wants to hire Olive, what are the steps they need to take?
Well, that's a great question. So we start with what we call an AWE, which is an automation workflow evaluation and estimate. So basically, we want to see what it is that makes sense for Olive to automate. I guess going back, the first step would be contacting us, and we would set you up for that. But what we find is when we talk to an organization, a healthcare organization, we kind of come in with the idea that we can help with things like eligibility, because that's usually low-hanging fruit. But then the brainstorming starts, and they think of, every single time healthcare organizations think of 10, 15 different processes. They know about some arduous process they're doing in medical records staff. They know about some document transfer function that's occurring. They know about something in revenue cycle that's just taking people's time, and it's a painful process. So we want to narrow down what the organization wants to start with and automate. And what we'll do is we have a technical product team that will go in and actually watch the human do the task. And we like to record that. After we sign a BAA with the organization, we'll record that screen of the human going through a process. What we'll do then is take back that recording, and we'll look through what we need to do to automate it, and then provide an estimate. And our system works in it's charged by the kilowatt hour, so it's kind of like electricity. Just like you plug in a night light into your wall socket at home, it's going to consume so much electricity. You plug in a refrigerator, it's going to consume a little more. We have a very equivalent system with AI through the kilowatt hour instead of the kilowatt hour, where some AI is very easy. We can just automate a web interface or automate your Meditech or your EHR, any EHR, or some of it requires some very heavy lifting from AI. Computer vision requires us to maybe look at and read scan documents, or handwriting could require some learning neural nets that we have to create so that the AI uses the best decision-making process, and that consumes a little bit more kilowatt hours than a typical kilowatt or a typical implementation. So we start with that. We start with the automation workflow estimate and go from there.
Okay. Next question is, what are the best ways an organization can structure around operationalizing AI?
That's a great question. So when we actually started in April. Basically, Olive started to get hired at organizations in April. We now have over 40 organizations who have hired Olive. And initially, we were she was being hired to do one task, and then the organization would like that. They liked those results, so they would talk to us about other tasks. And that's certainly one approach. But we now have, we've now created an offering that's a little more system-wide, that thinks about AI more as an infrastructure. And we call that the ASOC. And the ASOC is an Automation Support Operations Center. And this is where we'll go into an organization and help you set up a no-kidding operations center, in a small space with a few TV screens on the wall, where you're doing really three things. One is you have somebody dedicated to going through your organization and finding tasks and things that humans are doing today that could be automated. Ways to save money, ways to scale humans, ways to have better quality and better outcomes. And then the second step is the automation of that. So there's somebody, it's usually someone, it's a CrossChx engineer that's virtual, that does that automation. And then the last thing that ASOC does is measure, there's an intelligence analyst that measures the output and the effectiveness of that automation. So we think it's super important that if you identify a process, automate it through AI, you need to be able to measure that and say, here's the ROI we're getting. Here are the cost savings. Here are the missed revenue opportunities that we're gaining. Here's the error reduction. Here are the quality and improvements. So that's what the intelligence analyst does as part of the ASOC. It's constantly reporting on the effectiveness of that as kind of a not only to make sure that everything that we're doing has value, but also as kind of a sales tool internally, so that everybody in your organization understands how they could use AI, how they, a director of, patient registration could use AI through the ASOC to do that. And the way we do it is we set up the ASOC with those 3 positions, one being us. With the other 2 positions, it can be somebody from your staff. We also have a very sophisticated services company that does a lot of work in the intelligence community that can provide those other 2 FTEs. And then we have a kilowatt hour kind of account. And as you pick automations that you want to create and places for AI to work, we just pull from that kilowatt hour account. So that's the more systematic approach to making AI an infrastructure in an organization.
Okay, great. How does AI work in tandem with people?
That's a great question. In many cases, we aren't replacing a human outright. I know that those are oftentimes the gains that the CFO sees immediately and wants to go down that path. But in most cases, it's really working in tandem with the human. If you look at what a human does, an administrative employee, which, by the way, is about 40% of all the costs in most hospitals, as you probably know, these administrative employees typically do, several different things throughout the day. One thing may be a task that is ripe for automation, but what we try to do is take some of that off the plate. The way we think about it is if we can replace 10% of what 10 people are doing, that's the equivalent of gaining a whole extra human, and that's how we want to work. Is to gain efficiencies with the humans that you already have, to support them, augment them, and allow them to do more than they've ever been able to do before. So it really, Olive joins the team as another human. So, one of your humans is working on their workstation doing whatever they need to be doing. Olive is working on her workstation doing what she needs to be doing. It's not like Clippy, that, if you remember Clippy from Microsoft, that pops up in the corner and says, hey, knock, 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 you should do this. It doesn't work that way. It works just like another person that's doing tasks, and Olive can take tasks to kind of level or balance out what your humans are doing.
How do you evaluate the effectiveness and accuracy of AI or with Olive?
So we go through an auditing process during the beginning, early stages of going live with Olive. We consider this kind of her internship period. We try to apply, given that Turing model that we talked about, the kind of human principles to this. It's a a training or probationary period where she starts working in the health system. She's doing something that a human typically does. We usually have them working on the same thing in parallel for a little bit to be able to measure, to see, okay, the outcome of the human's work was X, the outcome of Olive's work was Y. Let's compare those. Did Olive miss anything? Did the human miss anything? Did the human provide the same quality as Olive, or Olive far superior? I can tell you in every single example that we have implemented today, Olive has always been able to catch more than the human catches and provide a higher quality and also a higher consistency. That's just the nature of the machine. There's a lot of variables in a human when they're dealing with a task, and they can obviously overlook things, they can miss things. So in every case that we've implemented today, Olive has exceeded the human performance. I will say though that as functions and capabilities get much more difficult and subjective, I can imagine a world in the future where the human has a higher performance of Olive, until we get our technology to a point that Olive can integrate a lot of that subjectivity that the human has. But for most of the tasks today, Olive performs higher.
What is the premise around patient information access, safety, and the onus when integrating AI into the hospital system?
So we follow all the same guidelines that you would have with not only a company that you're working with, but also a new human employee. We sign a BAA with the organization, and we care for their data in the event that we have some kind of storage capability. It's all done in a HIPAA instance. We usually use AWS HIPAA instances that are tunneled into your existing infrastructure. We can also host it inside your infrastructure if you give us a VM. So we follow all the same governance that we would follow, that you would expect a company to follow in making sure the data are protected. From the human side, from the Olive side, the same types of auditing capabilities that you have for a human baked into your software already is still in effect. We not only tell you what Olive is doing and has done, but your software, through its auditing capabilities, can also tell you that because it's just another user. When it comes to sharing information, it depends. We ride your current policies. We do not create new policies. So, for example, we like to share information with patients through the patient portal as a first course of action because that's already kind of a proved means and authentication route for information to your patients. So it'll literally be Olive logged into a patient portal communicating back and forth with patients. In the event we were to share information across 2 different hospitals, it would require permission of the patient themselves and certainty around the authentication that we're talking about the same patient. So we ride all the existing policies and we work within them. There's not like a new app that we're just sharing information between hospitals without following the current consent models that exist.
Well, Sean, that was our last question. I want to thank you so much for serving as presenter for today.
Absolutely. My pleasure, Scott. Thanks so much for inviting me. I hope it was helpful.
Oh, absolutely. It was great. So I'd like to also thank all of our attendees for sitting in on today's webinar. As always, we'll get the recording uploaded to the CSOHIMSS YouTube page within a couple of days. Thanks for attending, and we'll see you next month.